Let's talk about the half-angle identities. Here are the half-angle identities for cosine, sine, and tangent. So one thing to notice here, we have cosine of x over 2 is equal to plus or minus the square root of 1 plus cos of x over 2. And it's not to say that there are two actual values for cosine of x over 2, but it's to say that depending on what x is, depending on what quadrant x over 2 falls in, we might have a positive sign or a negative sign. And it's a similar thing for sine here and for tangent over here. So again, we pick the plus or minus sign in these formulas based on which quadrant x falls in. So let's look at an example. So let's compute cosine of 15 degrees. Well, remember that 15 degrees is in the first quadrant, so we know we're going to use the positive sign. We know we're going to have a positive value for cosine. And now the thing to notice is that 15 degrees is just 30 degrees divided by 2. So this is cosine of 30 degrees divided by 2. So we can use that, we can use 30 degrees as our x in our half-angle formula for cosine. So let's see what we get. According to our formula, we have plus or minus the square root of 1 plus cos of 30 degrees all over 2. But remember again, because we know that 15 degrees is positive, is in the first. Because we know that cosine of 15 degrees is positive, because 15 degrees is in the first quadrant, we know we're going to take the positive sign here. So we're going to take the positive sign and then compute the rest. And we can compute the rest because we know what cosine of 30 degrees is. So we find that this is the square root of 1 plus the square root of 3 over 2 all over 2. And we can simplify this a little bit more. So let's see how we do that. We would just multiply the top and the bottom by 2. And what that does is clears the 2 and we get the square root of 2 plus the square root of 3 all over 4. And then we can simplify a little bit more and just simplify the square root of 4 in the denominator. So that'll become, in the numerator, the square root of 2 plus the square root of 3, and then all over 2. So that is the cosine of 15 degrees. So now let's do one more example. Let's look at let's compute sine of 15 degrees. So like before, this is going to be doable because we know that 15 degrees is half of 30 degrees. So this is 30 degrees over 2. And now we can use the half-angle formula for sine. And what that is, again, there's a plus or a minus. The square root of 1 minus cos of 30 degrees all over 2. And like before, because we know that 15 degrees is in the first quadrant, we know that sine is going to be positive there. And so we're going to take the positive sign from that plus or minus. So we take the positive sign, and what we get then is the square root of 1 minus the square root of 3 over 2 all over 2. And we can simplify this a little bit. Multiply top and bottom by 2 gives us square root of 2 minus the square root of 3 all over 4. And we can simplify the square root of 4 in the denominator and get just 2. So what we end up with is the square root of 2 minus the square root of 3 all over 2. So that is what sine of 15 degrees is. As another example of what we can do, suppose we're not asked for a specific angle measure, but we're just told what cosine of an angle is, and then we're asked to find cosine of half that angle. So as an example here, if we're told that cosine of x is 3/4 and x is in quadrant 4, and we're asked to find cosine of x over 2. And now remember, the reason we need to be told where x is, what quadrant x is in, is because of that sign confusion. We don't know whether it's plus or minus unless we know what quadrant x is in. So having this information about x being in quadrant 4 will be enough to tell us what the sign of cosine of x over 2 is, because we'll know which quadrant x over 2 is in. So let's just think about that for a second. If x is in quadrant 4, that means that x is between 270 degrees and 360 degrees. So if that's what x falls in, then x over 2 will be less than or equal to 180 degrees and greater than or equal to 135 degrees. And if you think about what that range is within quadrant 2, right? So we saw that x itself was somewhere in quadrant 4, but x over 2 will be somewhere over here in quadrant 2. So that's where x over 2 falls, and we know that in quadrant 2 cosine is negative, because cosine corresponds to the x value of a point on the unit circle. So we're going to have a negative value for cosine of x over 2. We need to use the negative sign in our formula. So let's remember what cosine of x over 2 is. It's plus or minus the square root of 1 plus cos of x all over 2. But again, because of what we just said, we know what x over 2 falls. It falls in quadrant 2, and so we're going to take the negative sign. And so we now have everything we need, because we know what cosine of x is. It's 3/4. And so this becomes minus the square root of 1 plus 3/4 all over 2. And we can simplify that a little bit more. If we multiply top and bottom by 4, we get 4 plus 3 over 8. And we end up with minus the square root of 7/8. And we could rationalize that a little bit more, but that's good enough for now. We'll leave that as is. So that is what cosine of x over 2 is. All right, as another example, let's see if cosine of x is minus 2/3 and x is in quadrant 3, let's find sine of x over 2. Well, we can immediately write down what the formula for sine of x over 2 is. It's plus or minus the square root of 1 minus cos of x all over 2. And again, we already know what cosine of x is. We were told that. And so all we really need to do is decide whether you use the positive or the negative sign. And that's going to come with this extra information about what x is. X is in quadrant 3. So let's think about that. If x is in quadrant 3, that means x is greater than or equal to 180 degrees, but less than or equal to 270 degrees. And so, what will x over 2 be? X over 2 will be less than or equal to 135 degrees, but greater than or equal to 90 degrees. And what is that? That is an angle that falls in quadrant 2. So this is quadrant 2. And so knowing that x over 2 is in quadrant 2, that's a place where sine is positive, right? We know because sine corresponds to the y values, and in quadrant 2, y is positive. So And that's all we need. We now have everything we need, so we can plug into the formula. We get the square root, positive square root of 1 minus 2/3, that's what cosine of x is, all over 2. And if we simplify this a little bit, we get, 1 minus 2/3 is 5/3. So we're going to get the square root of 5/3 all over 2. And if we combine this fraction, we get 5/6 under the radical. And we could rationalize that if we wanted to, but that's good enough for now. So we'll leave that as is. So sine of x over 2 is the square root of 5/6. All right, now let's do a few more examples involving the half angle identity for tangent. So here we're given that cosine of x is 3/5 and sine of x is minus 4/5, and we're asked to find tangent of x over 2. And now with tangent, remember that there are several formulas for tangent of x over 2. What's nice is that 2 of them don't involve a plus or a minus sign. If you're told what sine of x and cosine of x is, you don't need to do any analysis to figure out what angle or what quadrant x over 2 falls in. So since in this case we were told what cosine of x and sine x are, we can use one of those formulas and we won't have to worry about what quadrant x over 2 is in. So in this case, let's say what tan of x over 2 is just 1 minus cos of x over sine of x. And in this case, we're told what cos of x is, it's 3/5. And we're told that sine of x is minus 4/5. And now just multiplying top and bottom by 5 to clear the denominators, we're going to get 5 minus 3 on top, which is 2. And clearing the 5 on the bottom, we get minus 4. And simplifying, we get minus 1/2. And so there's not too much to it. If you know cosine of x and sine x, you can figure out what tan of x over 2 is without too much trouble. Okay, so here we're told that cosine of x is minus 5/13 and sine of x is minus 12/13, and we're asked for tan of x over 2. And again, if we know what cosine of x and sine x are, we can find tan of x over 2 just by applying the formula without too much trouble. So again, we can plug in, we get 1 minus cos of x over sine of x. That's one of our formulas for x over 2, for tangent of x over 2. And now we just plug in what we know. We know what cosine of x is, 1 minus 5/13. And sine of x is minus 12/13. Now if we multiply top and bottom by 13, let's see what we get. We'll get 13 minus 5, so that's going to be 18. And in the denominator, we're going to have a minus 12. And if we cancel a common factor of 6 here, we get minus 3 halves. So that's what tan of x over 2 is.